Hi Shivam,
Hi,
what are we discussing today? I mean, what are you teaching today?
I'm I will teach today about the image processing kind of things how you can see about I show you some example in the first class the image segmentation where we see how we can see what is the ferrite phase and what is the pearlite phase in any SCM image or any microscope image. So I will show you that how that works.
Okay. K- like you had asked in the last class, lastly, whether we have some papers to paper I might want
Uh,
you to discuss.
you can
Uh, I'm curious, like if you can discuss one of the papers in some like AI and ML applied in rapid solidification.
okay. Can you send me that paper?
No, I do not have. Maybe I can share. I can find out and share.
Maybe if you have the link of that, or then you can.
Yeah. Can I have your mail ID?
Sorry,
Can I have your mail ID?
email
Email.
ID. Okay, I'm writing that in the chat box. You can.
Okay. Thank you. Thank you.
Hello, hello, Anthony. Are you have any question? Hello everyone, welcome to all of you. I'm Shivam Aggarwal, PMRA Fellow at the IIT Kanpur, and today I'm welcoming to you into the sixth NPTEL live interactive session for the course Artificial Intelligence and Machine Learning in the Materials Engineering, which is being instructed by the Professor Krishanu Biswas. And today, I'm going to show you like some case study. In this work, these people have worked on the image processing kind of thing. Like the title of this work is a novel training methodology for phase segmentation of steel microstructure using a deep learning algorithm. So from the title, it is you can see the phase segmentation of the steel microstructure. So they prepare a deep learning algorithm model. So by which by that algorithm they can easily see the segmentation between the what kind of segments are there in that microstructure. So for that purpose, they use some good approaches to synthesize to prepare a synthetic data. So I will show you that the what's the first why we need the segmentation in the microstructure. So phase segmentation is essential for the accurately understanding the materials property like its strength, durability, and the how it will be resistant to the corrosion. And if we got the if we identify the what different phases are there, what is the percentage of those segmentation are there, so we can correlate that with the some overall performance of that material, just like in the some mechanical properties of that material. And but when we try to do that, any optical microscope, microscope image, or any electron microscope image, so we have to do that manually, which part is what, that would be ferrite, that would be perlite. So we have to do that manually. So and then we have to calculate the area, the area of the different segmentation in that image. So that will take a long time, and it required a expertise in that field also. Uh, so as I told, traditionally phase segmentation methods involve the manually labeling of the each phase and using the point counting technique for the statistical estimation, how much each phase are there. And this method requires the significant expertise and are often labor intensive. It will take a lot of time. So you have to find with your PC and you have to see that image and put every area that would be what kind of segmentation are there, that is perlite or ferrite or any other. And this manual annotation and the point counting is a very time consuming. So by which we calculate the area. So that will take a time, expertise, and some labor thing also. So what are the ways we can do that on its own? That will we do, like we have a microscope image and our PC can do this thing uh, on itself without our help. So that's why these people are worked on this. How they can accelerating the phase, how they accelerate the phase segmentation with machine learning. Machine learning, especially if I talk about the machine learning in the image processing, that would be the deep learning approaches. They offers a very good phase segmentation things, especially if maybe you all of you maybe heard about the CNN, convolutional neural networks. They are generally used for the image processing techniques. So because they have a very good very good accuracy in terms of the image processing, like the segmentation of the image, so they can be used. So so if we use the machine learning, so it will and we will give it. that what would be the different segmentation. So if I give that new microstructure, so it will give me to the percentage of the every segmentation and highlight which area is what segment, like what phase is that. So in this work, they have also if I talk about the microstructure image. So if I collect the data for this purpose, so that would not be enough. If I take the data of if I want to produce the data on my itself, so it is not possible to take the image larger than the 100. And if I talk about the literature, in the literature, if I talk about there would be the different line time, different length scale, different conditions. So that data is not be suitable for this work because we required a very good data. For that purpose, they use a some innovative approach to produce the data. Uh, so first of all, then we will discuss that. So how they generate the data? Actually, they took two stage sheet. And with a specific chemical composition. Then they homogenize that composition at the 950 degrees Celsius for 20 minutes, and they do the annealing and the air cooling to develop the ferrite and pearlite microstructure in that shift. After that, they capture the micrograph of that sheets in 2000x and 5000x. And after that, they collected the overall 50 micrograph of the steel, first sheet, and for the 50 micrograph for the sheet two. So they got out overall 90 micrograph calculated, and after that they crop the image in the pearlite region and the ferrite region, and they got like 28 ferrite regions and 58 pearlite regions. By using these uh, cropped image, as you can see here. These are the cropped image of the pearlite image and the ferrite face. So after using this cropped image, how they use this? First of all, they created a, synthetic micrograph. Like they generate templates by simulating the nucleation and the growth in a 3D polycrystalline structure following a Abramic kinetics. So they start with this, they have some points in the 3D region. After that, that points nucleate and the growth will happen by using these Abramic kinetics, and they got after that they got this kind of structure, kind of micrographs from there. How they got that? Like just suppose there is a 3D maybe uh, there is a kind of a 3D uh, block, and every bubble is get nucleated and they grow. So they got touch each other, and that overall things get that 3D cube get filled by using this nucleation point and in the growth of those nucleates. After that, if I cut those segments in cut that cube into the segment, then I will get this kind of plot. So by using these plots, they created a synthetic data, and they also adjust some nucleation rate and the growth rate to create these various grain size and the distribution. So here you can see, like if they increase the growth rate, they get this kind of course, and as they create a nucleation rate, how they got the microstructure. So now what they do? First, they created this kind of micrographs, but here nothing is a pearlite or ferrite. And in the first part, they get some pearlite structure and the ferrite structure by using the experimental technique. And there are the 28 ferrite region and 58 pearlite regions. So now they generate the data. How? They select the polycrystalline template, which they got in the experimental technique, and they superimpose that crop image into that template. You can see here. Like you have this template. Now they use this cropped image of the ferrite and perlite, and they cropped this image, and they created like just for example, this image filled in this yellow region. This image is filled into the this kind of blue region. This image is filled into the this region. So in this way, they created a different kind of microstructure, and they rotated this image. They flipped this image. So they got a very large number of synthetic data by using this technique. So now, if they want to, this is the flow chart how they do that. First of all, they got this polycrystalline template. They select the grain, like in which grain they uh, feel about the ferrite or perlite. So first of all, they select the grain, then they resize that image. Like this image is cropped according to this this size. Then this cropped image is rotate or super. Hello. So after that, they rotate and superimpose that structure into this. After that, they merge these would be the joining of these two kind of phases, like here this joining and this joining, and they merge this joining by some smoothing kind of thing. Like they smooth that edge. Like there should not be like some synthetic kind of thing. That would be like some real thing. Now they created this artificial micrograph. Then they labeled that like first of all, I have to give the my ML model to the data, like what would be the perlite, what would be the ferrite. So for that purpose, they label the data like this is perlite, this is ferrite, the kind of thing they can also alternate. After creating this large number of data, synthetic data, they use a technique which is called the UNet. What is a UNet? A UNet actually is a deep learning algorithm which is generally used, and it is a generally people are used in the like uh, in the medical application to produce to get the different kind of features. And this the flow chart of this algorithm is look like this. Maybe many of you don't know about, maybe do not be understand. So you can understand in this like this process is called encoding. Like they encoded the data and they are decoded the data in this reason. So how this work? Uh, Unit is a special type of neural network used in the image segmentation, which means it helps to identify the separate different part of that image. What is the use of, what is the purpose of our work here? So it is widely known as in the medical imaging, as I told earlier. And unlike the regular neural network like the CNN, it is a kind of a unique U-shaped design with two domain part. First part is the contacting part. What that do? That reduce the image size to capture the important feature. Like first, if you see here, that is reducing the its size. Like if you see the size of the image is increased. So the pixel size of this image is decreased here. Like if you see here the 1024, and this is a sorry. This is a if you see the like this image is the like 512 into 5 into 512 pixel, and this is the 256 cross 256. This is the 128 cross 128. But here you see this is the like 64 neurons. Then it is a 128 neuron. Then it is a 256 neuron. Like first of all, the neuron size is increased, which is like 64 to 1024. Then it is getting decreased again. So that's why it is called U U shape. And the second part, expanding part, increase the
Excuse me.
image size to sorry.
Neuron sizes are increasing or neuron numbers are increasing?
First of all, the neuron Sorry, neuron number of neurons means in a particular layer.
But you said neuron size, that's why I couldn't say.
Sorry.
You have said, sir, neuron size, right? That
Yeah.
confused. Neuron numbers or size.
Yes, sir.
Sir, up to now, we did not cover deep learning, like you said. We can't understand this thing. I think so.
Sorry. Can you
In,
write your
se-
question? Actually, I'm not able to understand what you are saying. Actually.
in at present sessions, we are going that videos, watching videos, right? In that,
Yeah.
up to now, we have completed up to classification only. We have not
Okay.
came to deep learning model. Whether we can't
So
understand
that's
this,
why.
I think.
That's why I'm not gone through this like how this neural network is working. I'm just giving you the flavor how you can do that.
Okay.
Okay,
Yes.
I'm not going to like
Okay.
how the deep learning model is working here. So for simplification, I told you like there is a in a when we work on the neural network, there are some different layers. That is called the hidden layers. Okay, and this is called input, and this is called output. Okay, and in particular hidden layers, we have to give the some neuron number. What that neuron number do? The neuron number do give the some weightage to that particular to the particular feature. Like if you see this image is the 64 by sorry, this image is the like 512 cross 512, and it changed into the 256 cross 256. How do they do that? They give to the some weightage like maybe it will be too early to like explain how this algorithm work. Maybe after when you go through the neural network, maybe that will be uh, going into your mind how these things is work. So first of all, you can learn about this. This is the neuron number in that particular layer. Just that would be enough for now. Now, first they increase the new sorry decreased sorry they increase the neuron and then they decrease the neuron. The first part is called contracting path, then second part is called the expanding path. So that's also about the how this algorithm work. Like first of all, we start with the 512 cross 512 pixel, and then it go through the contracting and to understand the overall context. Then it use the expanding path to sharpen and the localize, making sure to the different part of the image are clearly defined. If you see here, this image, okay. So first of all, that is compressing its size. Like if you see this 512 cross 512, and it is gone to the 28 cross 28. So in this thing, it gone through the how many features are there. Like first of all, that create this image into that algorithm. Now, in this contracting path, it create the actual image of this, like that mapping of this image. Like what would be the pearlite part, what would be the ferrite part, and create it in this image. Now, if you see here, maybe gray region and black region would be shown here. So this black region converted here in black, and this grayish region converted into the like white part. So there is a like a 0 1 kind of thing, like one for black or one for white and zero for the other thing. So this is how this algorithm work. So after using this algorithm, they like in the previous lecture we also discussed about the like the tuning of the hyperparameter. Like in this thing, there is some hyperparameters like the learning rate, how your model is getting learned. And there is some other things, the epochs, like how many iteration it will do. So if I talk about the learning rate, if our learning rate is too small, so our model take too long time to reach uh, uh, its learning point, like where it will got the highest accuracy. But if your learning rate is too high, then it will not able to reach that your minimum that is your that this point. But so you have to make your learning rate is such a that that will be able to learn all the things in a small time, as well as it will go to the like with the high accuracy. Like we need uh, it will do into the small time, as well as it will get the like higher accuracy. So if you see this chart, this plot, like when learning rate is about a point 0.1, it is about the like a very there's a validation accuracy is a very like there is a some kind of noise. But if the learning rate is a 0.0001, it will take a very long time to reach to the very high accuracy. But when we increase the learning rate in the exponential decay, if you see here, first the learning rate is very high, then it decrease, then it decrease, then it decrease, and it is decreasing at the very low value. So it is they do about the learning rate, they decrease the learning rate into the exponential decay. If you see here, this is a red line. So it is get like validation accuracy good, and then it is a there is a non-noise kind of thing, and it learn so it do into the very few number of epochs, as well as it would get a high accuracy. So they optimize this, and as well as they optimize about the epochs, how the epochs will do into the ML model. So here you can see as the number of epochs are increased, the accuracy got increased. But you can see here after a particular number of epochs, there is a no significant change into the accuracy. So that's why so we can also tune our epochs also. So there is a no need to be a large epoch. So because that will also got your model is trained in uh, so your model got the significant accuracy before that. So there is a no point to train that to the higher number of epochs. So in this work, they also tune that. So how that model work? Now, see, this is the your green. Sorry, yeah, green region is the perlite region, and this black region is the ferrite region. So this is the artificial micrograph which we have. Then this is the ground truth, like what is the actual perlite and ferrite region. So perlite region is the green one, and the ferrite region is the black one. So this is the what we have manually do. Now, what is the prediction? If you see, this is the prediction for our model. So this graph is predicted by my model. If I compare these two plots, so I will see there is a nothing change here. Like there is a no significant change. Maybe some at some point there is a some error, but they look like exactly same. This is the artificial plot. This is the actual plot. Like this is the actual micrograph of the perlite and ferrite, and this is the ground truth. What is the actual ferrite region and what would be the actual perlite region? And this is the predicted segments by our trained ML model. And you can also see here they look like the same. Like there is a no nothing is changed here. Like there is a no kind of error. So we can say our model is doing great into the prediction of the perlite and ferrite region. Here these also the some examples they used to show their models accuracy. So this is the actual micrograph, and this is the ground model prediction, and this is the actual like ground truth, like what would be the perlite region and what would be the perlite ferrite region. So here you can see there is a no significant change in these micrographs, and same as you can see here. So this is the how people can use machine learning to segmented your image. Like maybe many of you are from the matter science background, and they are doing these things like what would be the perlite region and what would be the ferrite region, and not only this kind of thing, but there are the various thing people generally used where they segmented the image. Like one, they want to talk about the ratio of the areas. Like what would be the difference between this area? What would be the ratio of these areas? Like if I talk about the like what is the percentage of the perlite region and what is the percentage of the ferrite region here. So you can use that. So this is the how you can use the machine learning. So now go for the like how these kind of things work. So I'm not going to show you how this work is happen because this will be I'm not about I don't have the data for this work. So I will show you the some and that will take also the long time. If I have the maybe if I will have the data, then it will take a very long time. So I'm not going to show you that. So I will keep with the a small example. So I'm going to show you that. Uh, Vishnath, you can do with like all real image also. But that data should be the control data. Like there should be not the high variance in the input. Like if you talk about the like magnification, there should be the no large change into the magnification. Is UNet similar to the autoencoder? No, UNet is not similar to the autoencoder and the decoder. It is a different thing. No, they use that heat rated sample and they get the microstructure of that. After that, they uh, use that image, that cropped image of the perlite and the ferrite region to create a synthetic data. And after that, they also uh, make the prediction for those data to get the these. Maybe I show you in the last slide. This is the image of that. Like they compare here what is the ground truth for perlite and the ferrite region and what is the predicted value. And these are some other samples they also use, not from this like after from the literature or from anywhere. They are not used into the training part.
So in future, this model can be used for predicting the
Ah,
microstructure.
sure, you can use that.
Okay, sir. Okay. So what is the error percentage, sir? Is there any error factor considered? Error,
Sorry, error.
error.
Ah, there are the like kind of I think 90% error or sorry 90% accuracy. Maybe.
Okay, sir. Okay.
One minute, I'm
So like this, can we use the data from literature also?
You can take the data from the literature, but you have to be like the data should be the control data. Like uh, there are not things to be changed.
Okay.
Like
So parallelly we can conduct experiments, and from that
you
experiment
can do
we'll
that.
take the images and we'll train using those images, right?
You can do that.
Okay. So many works are done on this right now, or is it an emerging area?
This is an emerging area actually, but many people are working on this. Actually, there is a
Okay.
boost into the machine learning for the material science after the COVID.
Okay. Okay.
People are working from the like last 1 or 2 decades, but there is a boost after COVID.
Okay. Okay.
One net I am showing you to the hello.
Sir, now how can we at present I have some parameters. I have to do something work related. It's related coding. Now I want to take some parameters related. I want to survey the literature like that. If I want, my voice is okay.
So sorry, can you explain your question again? Actually,
Sir, I have to do coding. Whether I want to survey literature, like I want to do what to know which is the best. Otherwise, I want to predict. I want to train my model, which can be the better parameters. But if you want, I want to and know about that parameters. Can I uh, can I give all the papers like that also? Otherwise, I want to give such parameters on parameters that collect of that parameters only.
so maybe if I I'm maybe you are asking about like if you have any data and you have the some parameters, so you have to check which parameter would be the highly correlated with your output, or you can choose some other parameters alter like
No, which will be the better? The prediction also whether it can by knowing of all of these parameters, it can be also better like that. It can be predicted, right? That's like I am.
yeah, that would be better actually. That's why you are needed to the machine. Otherwise, machine will do everything.
No, no, my doubt is now whether I want to give. Okay, can I give a paper all the papers and train that you should take these parameters. Otherwise, I want to give that's parameters only.
Can you write your question? Actually, maybe I'm not able to understand anything correctly. I
मैंने
think.
मेरे अभी मेरे को अभी वो पैरामीटर्स पेपर्स रहते हैं लिटरेचर पेपर्स वो लिटरेचर पेपर देके ये पैरामीटर्स तो लेना पड़ेगा बोलना है क्या अदरवाइज whether I want to train that only parameters from that papers.
Maybe if you want to say like you have a different parameters.
Yeah, yes.
So you have a different parameters and you have a one output. So you want to use all the parameters or you have to choose some parameters from those.
Yep.
So you can do with the like some like feature importance kind of plot. So you can attain your model by all the parameter first of all. Okay.
Okay.
Then you will get the some parameters show the highly correlation with the output property, and some will not show, not going to contribute anything. So you can remove those. As well as you can also do the same, the different thing like as we do into the third live interactive session. In that work, they use some correlation. Sorry, they use some technique to reduce the size of the parameters features. Some wrapper method, I think. 1 minute. How many parameters, by the way, you have?
So many there are so many parameters according to the literature in so many parameters.
Okay.
No. Parameters means like it's like nearly about 5 to it will be take 10 to 11 parameters.
Okay.
In that particular, you have said right, which will be the you said about like this, which will be the most effective parameter we can know about like that also.
So you can do about the like you first of all train the model by using all the parameters. Don't be selective for those. Okay. Then get the
Okay.
feature importance plot. That would be the best way. Otherwise, you can also plot the heat map for those all the parameters with the output also, and you can get the some input properties have the intercorrelation also. So you can remove one of those property like two parameters giving the same information. So you can remove one parameter.
Okay.
In that way, you can reduce your size of the input. 1 minute, I am facing the problem in the Google Colab. If you guys have any other question? Please wait. Actually, I'm stuck in. Vipin, you can use the Google Colab if your data is small. Otherwise, I will prefer the Jupyter. You can download the Anaconda. You will find the Jupyter there. And other software also, Spider and but Jupyter is the kind of best for this kind of work. If you have not any question, we can take a break of the 10 minutes and we will meet after that around 6, sorry, 7:10. Is any work being done in the metal matrix composite materials? That should be. Maybe I don't know about maybe is there any work have been done or not, but there should be. By the way, what kind of work you want to ask? Like just metal matrix metal matrix composite, metal into metal, metal plus metal composite, or metal some other
Metal,
ceramic,
you'll add some reinforcements like silicon carbide reinforcement. So you
like
can
metal
vary
plus ceramic.
the yes.
Okay,
So
maybe there
for
should be.
predicting the microstructure of
Okay, I got it. There should be actually. I don't see anything till now because I'm not working in the metals. So I will, if I see, I will also discuss that. Or if you want to
okay, sir.
show me any paper or you want to understand that, you can send me that. I will show you in the next class
Okay.
how they work. Uh, maybe now I can't tell about this because my code is not working. I don't know why. Actually, I am facing the problem in the like loading the data. Actually, there is a image kind of data that's create a problem. Maybe I will troubleshoot that in 5 or 10 minutes. So please, you can take a break and come back after 10 minutes. If you have any question, you can ask me.
Good evening, sir.
Good evening.
Sir, my name is Anthony. Actually, I'm working in
Hi, Anthony.
metal matrix
Okay.
composite, sir.
Okay.
In this our experiment, we got microstructure. That slide already you shown in today lecture. After
Hmm.
getting the microstructure, how the machine learning AI tools we can use for further research, sir. That's only I have to know
Okay.
whether we have to study the program or coding like that, or what are the requirement from our side needed to do the link AI with the material microstructure, sir.
First of all, you have to decide your problem statement, what you want to do with that microstructure. Just the segmentation of the phases, just as we do here, or you want to do anything else.
Yes, sir. Segmentation means that actually the microstructure, some micron level it is there. To know
Okay.
the some in the phases are appeared in the in our experiment, some intermetallic components are phases. So in AI, how it identify the material structure, or how it related to microstructure, sir? That machine learning.
You want to extract what is the what are the phases there? How many percentage are
Yeah,
of
sir.
how much percentage of those metallic phases are there, na? I think,
Yes,
or
sir.
anything else.
Yes, yes.
Okay. So for
Yes.
that purpose, first of all, you have to create your data. You have some images. For example, you have the 100 images. Okay. So first of all, you
Yes,
have to
sir.
create an input data. For the input data, you have to give to the machine what are the phases are there. First of all, you have to give itself what is this region, what is this region, what is this region. Okay. So
Okay. Okay, sir.
then you have your input data, and then you have your output data. Okay.
Okay. Okay, sir.
After that, you will use that into the machine learning as an input and output.
Okay. Okay. There is supervised learning like that.
Yeah. Actually, that's the supervised learning.
Okay. Okay, sir.
Maybe you got your answer or anything else?
Yes, sir. I understand. In further lecture and problem solving session also, I can learn something related to this, sir. Thank you, sir, for your clarification.
Okay.
Sir, like that only, sir. I want to know the. I have some papers related to a coating, sir. I want to do a coating.
Okay.
Which coating is whether I want to know we want to prepare a solutions, right? With some
Mhm.
compositions. Like that,
Okay.
we by that preparing the compositions, we'll get a coating.
The solution you are sorry, solution you are telling that the solid solution or like a chemical solution.
It's a chemical solution. It's a chemical
Okay.
parameters like that.
Okay. Okay.
After preparing the solution, we will do the deposition, right? Coating like that. But
Okay.
every deposition, something parameter, something characteristic will be vary. By that,
Okay. Okay. I got your question now. So you are
yeah,
talking about the your processing parameters.
yeah. I want to know
Okay.
which
So
parameter is a better, which parameter can be better, like
so
that.
there are the
How
many
can I train the data?
statistic. So there are the different kind of statistical techniques. So you can do with the machine learning also, but there are the some other statistical techniques if I give the example, Taguchi method.
Topology. Okay. Topology method.
So
Yeah.
this kind of method
Three
you can
methods
use.
also. Three methods are there.
Ah, so you can use that, those kind of thing. Otherwise, you can do also from the machine learning. Like first of all, you have to try with the you vary the composition, you vary the concentration, you vary the temperature, and you created a grid type data. Okay, then you uh, you take the output of those composition. Like was you got what property you are measuring?
It's first note. It is not about properties, sir. But I want to know whether it will be known after the coating is
Like
better. Is not.
how you judge your coding is good.
By checking the microstructures like that, and by
Sorry.
doing some by checking the microstructures, sir.
Microstructure. So what you see in the microstructure kind of?
Otherwise, starting only we can see whether it is a delaminated or like the
I don't know. There's a but there should
bonding.
be like some percentage thing also maybe I think. Like you got coating over all the material and there are uh, some areas where coating have not been done.
Okay.
I think you have to first convert these things into the. Otherwise, the Gucci will be the best. You can because in that you can do that the delaminated or laminated. Otherwise, you can also do
Okay.
into the classification type of problem here.
Okay. But
Okay.
first, I want to know whether not at all, sir. First, so many papers will be there, right? I have taken
There are the
like
lot of
that papers.
parameters. So first of all, you have to think what parameter maybe play the crucial role. If you are talking
Okay.
about the solution, so there would be like the about the solution. If I talk about the concentration, first of all, then after that concentration, there's a parameter would be the temperature also, like a temperature of your substrate and the temperature of your solution.
It's
And so this kind of parameter you can take. Or how you deposit that, like some any process like spin coating or
it's
what?
electrolysis deposition.
Sorry.
Electrolysis deposition. Electrolysis deposition.
Okay, so
Electrolysis deposition.
so there would be
Without
like the
current, it will.
electrical current also, I think.
No.
Those
Without
parameter
current,
also.
it will deposition. Without current, it will be deposition.
Okay. So okay, electroless. So
Electrolysis.
concentration and the distancing between those plates.
No.
One minute.
It will be there.
No.
There will be
Electroless
no.
coating is a different. Okay. Got it.
We'll prepare the first solutions like
Then
reducing
you dip
agents,
that.
somewhat like in the dip it, and we'll maintain it at some certain temperature, maintain pH, certain pH for
So
something
that is called the dip
processing.
coating also. That is called the dip coating also, I think.
Like that also you can call. But it is better to call electrolysis deposition only because of
I
they-
know. People sometimes call this actually. Then we talk about the like the electrode deposition. Then we also discuss these things. Okay.
like that. But coming to the first temperatures, pH, room, that thing only. First, we want to know about the solution which I want to take 28 something for nickel sulfate. I want to take this. There's something like that we will take, right? This much of gram
Okay.
per liter, like which will be the better.
What will the
better.
concentration, or maybe use some other solution also. Maybe I think if I'm right, some buffer solution also you used maybe I think like
we will use for controlling the pH.
for controlling pH, and there is something like that to control the rate of the deposition and to
Yes.
get the some fine structure. There
Mm.
are some other things also there. So you can
Like
also optimize it, like what concentration of those things you have to use.
By how, sir? By classification or something? Like what type of
You can
model?
you can use here the classification. Maybe that would be the good, because you don't know, like you are not measuring any numerical value here. So you can divide into the two part, like deposition and the not deposition.
Okay. After
Okay.
that, the
After that, first of all,
deposition parameters, I can take that
as
for that
input.
I will get values, right? For that,
Yeah.
for that
You can use those values also. You can also vary into the like 0 and 1, like yes or no kind of thing.
Okay.
Like just suppose you are using the three kind of the different buffer solution, just for example. So you want to take like the which buffer solution give me the best result. So you can take this like this buffer solution is used, yes or no. This buffer solution is used, yes or no. Okay.
But
You can
it
also.
will be vary for a particular.
So that's why
if for
that would be the best if you use the numerical value.
okay.
Use the concentration of those, and your model that will if you are not using that, then it convert into the 0. Is collecting data from the published literature and then make that data set to train a model worth it, as it don't have resource. It would be the worth. But you have to be precautious to selecting the data. Okay. Many people are working on this kind of thing, like they collect the data from the literature and do the things. Like I'm also doing the same. I take the data from the literature and use a machine learning for that.
You will take a train, you will take a data, and you will use what you want to model, like that, sir.
Yeah. Like first of all, you have to take the output from the data, na. So you will select the literature where you get those output. Like just suppose I am working on the like the halide perovskite. So for those things like the band gap is a crucial parameter. So I will go for the literature where I have the composition as well as it's the band gap. Okay.
Sir, you are now working on which, sir? Allied perovskites photovoltaic application.
Yes. Yes. I'm working on the electroskites.
I have listened a lecture on a workshop, sir. That's it. By Dr. Abhishek Tiwari. He is also
Okay. Maybe I think in the IT Roorkee, if I'm right.
okay. I want to
You
see.
are,
I
you
have
are
went an
from?
IAM. I'm from now I am working in
Oh,
CMER, sir. I have listened that workshop. I have went to that AI materials engineering by conducted by IAM.
okay.
On that, I have, he said about that thing.
Okay.
ABX3 sometime I have seen that.
AVX3. Yeah.
Mm.
AVX3 is the structure of the perovskite chemicals.
He said about tolerance factor what, and on that time I have not understand because I was new to that thing. But now,
Actual tolerance factor is a kind of a thing by which you can estimate that this metal will be formed or not. Like for the ABX3 structure, there should be a particular tolerance factor. If, for what it would be the halide perovskite or not.
if it is created by ML or it's algorithm, right?
Halide perovskite is a name of the material.
No. I'm
Like is
sorry.
it
I'm
okay?
tolerance factor. It is. I'm
Ah,
getting.
sorry. Tolerance factor is a ratio of the there is a formula that have the radius of the anions and cations, like radius of A, radius of B, and radius of X. So by using the radius, like dimension, size of dimension, you can use that. You can check that the tolerance factor of that composition.
This.
Yeah. Ah,
There will be
hello,
some error functions will be there, right? As it like sigmoidal function, somewhat like so many functions will be there. Why it
yeah.
is how we can know where that error function we can use or like that.
Actually, the simple answer of this, you have to check all of this because that would vary with your the relation between your input and output. Actually, in the material science, we generally don't know about the relation between the input and output properties. Generally, that is the non-linear relation. But what kind of non-linearity they have? So you have to check that. So if you know about that, so you can easily say what kind of loss function or what kind of algorithm will work on your work. Otherwise, you have
But
to work with
most popular they are saying the sigmoidal function we can use so many for error functions
generally
like that.
because they are like something the universal thing kind of. So that's why people are. But that is not limited to that. There are the more advanced things are also there. So you can use those also.
But it is easy to use, right?
Yeah, yeah. It's widely used.
Okay, sir, thank you.
Validation. The data. Ah, I'm going to show you some work of what people have done in the Kaggle. Actually, I'm not able to solve my problem. I don't know why this is happening. Maybe due to the large size of the images. So one minute. Ah, So maybe you are able to see the screen. Are you able to see? Hello. Okay. So if you see this code, first of all, the libraries are imported. Then the some common libraries are imported. Then they load the data. How they like select the data. So these are the some libraries. Then after that, how they manage the data. Like you have the images. So how you can use them. So there are the different thing by which we generally used the image like you have a colored image, just for example. Okay. So first of all, for the machine, any machine, you have to convert your image in such a way that your machine will get the information about from them. So generally, any ML, generally in any ML algorithm, convert your image in such a way that will be first of all, the scale of the color is going into the between 0 to 1. First of all, it will judge the color 0 to 1. Like there is some gray region that will be some 0.5, 0.6, 0.7 value. And if it will be like a 0, that will it lead to the 0 value. So, and there are the some other things. So that will determine the contrast of the image, sharpness of the image. So there are the various things. Those things are generally not be used by ourselves. So machine learning model do those things on itself. So that is called the mask. So those are the mask that is your algorithm is do with the material, would do with the images you give to the model. So the images are saved by using this command, and these are the some how the image you can see. So this is the masked image you can see here. This data is about the breast cancer data. So here you can see these images, and now this image is converted into the mask. So here the mask of this image is shown. So that is converted into the image into the mask thing. So this is the cancer cells or not. So this is the how you can see the data, and as you can see here, the color data is converted into the binary like 0 to 1. It means it will convert into the black to white. So it is something by which you can featureize your data. This is not like a classification or regression problem where you have to for the aspect ratio. You have to maintain the aspect ratio of the any microstructure as well as its pixel size also. So you have to maintain the pixel size of the all the images. Like just for example, in the work which I show you here, that is about the 5122 cross 512. So after that, data is converted into the mask. So this is the data which you can see here, and this reddish region is maybe I think for the cancer cells. So these are some things in which they converted into the different kind of thing like they see this with the copper color. They see this with the M for AFM hot. This is some color mapping. And after that, they encode the image into the thing. Your machine can control that. So as we see about in the unit, so first of all, that convert the encode the image, then it decode the image. These are the some definitions. They like what would be the activation function, what would be the kernel initializer, what would be the padding, what would be the filters, what would be the kernel size, what would be the strides. So they use this, and same things they have done in the decoder part. And after that, they create a attention gate. Attention gate is just a kind of layer which merging your data kind of thing. So maybe don't think too much about this. So this is the custom callback, and this is the attention unit. So this is the your overall what is the your unit? Like we have defined our uh, things like in what would be the encoder, what will be the decoder, and attention gate and the custom callback. All by combining all those things, they make a model which is called UNet here, and then they give a name here. It's calling output layer model. Is they give the model to the your UNet model name. So after that, base size they give into the base size is 8. SP is the length of the images divided by the base size. It means it divide into the data into these parts. Then what will be the result? First model have to be fit on the images on the mask, and it is the validation split. Validation split is the same as we like 10 test split. Like it will split the data into the two part. First of all, the training data, and then this is the validation data. Then this is the epochs, how many times this code will run, and this is the steps per epoch. Oh, sorry, steps per epoch. It means how many steps it will do on to the per epoch. And this is the batch size, and this is the callback. So after the running the data, uh, they got this kind of results, and after all the things they evaluate the data, and what would the evaluation matrices? Loss, accuracy, IOU. These are the some evaluation matrices in the like segmentation, and they plotted all those things like what will be the IOU, what will be the accuracy for the training, what will be the accuracy for the validation. As you can see here, with the with varying the number of epochs, how the accuracy is changing here. And these are some images, and its output, how these are like this is the original mask, like what should be the, and this is the predicted mask, and this is the processed like overall output. So here you can see these are like approximately same kind of thing if you see this and this. So here is the problem in this, so it's not a quite good validated. So there is the some notebook which you can see. Maybe this is the notebook which I am working like here I loaded the data from the Keras, but maybe that's not worked. Then that data there is a data about the like a cat, dog, and different animals, and then it will be detect about the what kind of part is filled with the any animal. So you can detect like there are the cameras in your room, in your hole, just suppose, and you want to see there is a any animal or not. So your camera detect by using the capture that image, and your ML model see that is there any cat or any dog there or not. So that was the example I want to show, but maybe not visible. Yeah, I also want to be stick with the data like, data with the like materials. But if I take the data of the materials, that is the very the huge that will create a very that will need a very huge space. So that is the problem with the that kind of data. That's why I'm not go for that. But maybe I'm not. I'll not also show you about the different kind of data also. Maybe in the next lecture, I will try to do that. If I got any data with the like related to the materials. Yeah. If you want to any question, ask any question, please ask me. Otherwise, I will going to end this session. And
Sir,
sorry,
it's
maybe.
not. It's not about question doubts. I have a personal. Sir, I completed my BTech last year. I have to do in career in AI materials engineering like that. Uh, when I'm searching, so very less universities I have seen about in masters like that. Whether I want to page, I want to do PhD also, which will be the where how I can approach to them like that, because I have not a lot idea about this thing, right? So that's why I'm entering some workshops like courses like this. I can learn something like that.
Okay. So, where you are now, like, where you are doing your masters now?
No, I'm not doing masters. I want to do masters. At present I'm working as a project associate in CMAR at Tulkapur, CSAR. It's a lab.
Okay, got it. So now you are like as a JRF and a project employee.
No, it's a project associate. Project associate.
Okay. Why only one CNN architecture unit? This is not same like. Whose mic is on? It's not visible. Okay. So, anyone have other question? Okay, Vishwanath question. So Vishwanath, this is not a like CNN. Actually, CNN is working in the one direction also. As it is a kind of a unit. So there's it's a CNN, but it's a different from the CNN. Maybe after when sir have done with the artificial neural network, I will go for that. How these kind of things are work. What is the difference between the CNET and CNN and UNET? But maybe the scope of this course is not wide that so I will we will discuss about this advanced algorithm, I think. Is there any other question?
Sir, I
Ask
have
us.
asked any suggestions, sir.
Any suggestion like
Whether I have seen some universities, but compared to the whether it is it's a private universities, I have seen so much cost like that.
okay.
But which can be the what can I how can I approach whether in this era?
I'm also from the state university. That's not the thing like
Ah,
it
you
will
have
create
completed
any
MTech,
problem,
sir.
I think.
You have completed MTech like
I,
that.
I have completed like my MSc physics from Meerut University.
Okay. How do you approach in this project like it is in ML, right?
Like you can give some competitive exams like so you can enter here like you can give the gate exam or net.
By entering this, you have learned so many like you before you are entering, you don't know about this ML like that.
No.
After entering only, you
In
have
my
learned
PhD,
this thing.
I have learned all these things.
Okay, sir.
That's
Thank you.
not like you will get a very long time. In like in one semester, 2 semester, you will be pro in this reason.
Okay, sir. Thank you.
Vishnu, there are the various websites which are they also have the data, so you can use those data also. Like if I talk about the like Citrination. By the way, what kind of data you want? Like in which kind of data you want to work? Corrosion. Maybe I don't know about the corrosion data, but there are the various open sources websites. They have the various kind of data you can use for your research purpose. Mm. Is there any other question? Bhaskar Vipin. Okay, let's end this session. And sorry, I'm not going to present today anything. Maybe in the next session, I will show you the how you can use the UNet. Maybe not the UNet. I will go for the CNN because UNet will require a very high time and very high computation power. So in the live session, it will not be possible to show you. Okay, thank you so much. Let's meet in the next session.